Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of TransPower Corporation, a commercial and custom software manufacturing and certified systems engineering company. I work as a theoretical physicist and as a systems and mechanical engineer. Today's screencast, my weekly screencast, will be about the reciprocal system as usual. Specifically, the Reciprocal System Microcosmos database. You can see the menu for the Microcosmos database on the left side here, and the menu for the Macrocosmos database on the right side. I've already covered these on the right side here in previous screencasts. Over here in the Microcosmos database, I previously have covered interatomic distance, valence, specific heat, energy and entropy, thermal expansion, compressibility, and electrical magnetic properties. So today we're going to look at isotopes. So we just click here, it comes right up. We'll stick with iron for today, but then we'll, when we get down to alpha radioactivity, that's when the atomic number is greater than 82, we'll switch to uranium. Okay, so the top line here, the top row, same as usual. The element, compound, or mix goes here. The description, the form number, atomic or molecular weight, million temperature, thermal factors, compressibility factors. Okay, now the screen doesn't have too many inputs really, and I've already filled out all of these for the elements. So we have the lowest value of G. G is the isotopic or gravitational charge number. That's the lowest value, -7, and the highest value is 20. You can have negative and you can have positive, it doesn't matter. The mid-range is 4.321024. That's calculated. Here we have the AMU and U. These are slightly different. Just make a note of that. U is the newer type number, but AMU is more closely related to the reciprocal system numbers. Okay, now this column here is the isotopic charge, so we go from -7, that's this -7 here, all the way down to 20, which is this highest number. And we have the AMU, which is just a whole number, and then we have U. Okay, slight difference, but it's important. Here's the mass defect. Again, AMU and U. And if you forget, there's always the tooltip. Just look at the tooltip. Point the cursor at what you see on the screen, and there you get it, the number of isotopic charges. This is the mass of atom of mass number A, including G units of isotopic charge, taking into account the mass defect. So this is the calculation right here, in AMU and in U. And here we have the secondary mass, which is the mass converted. Let me just bring this back up here. Mass converted into energy and radioactive decay. Pretty small numbers, you can see. Okay, so that takes care of that. Now let's switch to uranium for the alpha radioactive part of this. So let's go. We click on Show All. Then we click on Find, and then we'll put a U in here for uranium, and there it is. So we have the same information. We start at 33 in this case, and we go to 56. Everything is positive in this case. G, the mass defect, the total mass of the atom, and then the secondary mass, which gets converted. Now in this case, we can choose the value of G, and in this case we'll choose 54, which is right in the mid-range. And the observed half-life in seconds goes here, and then the program calculates the output in million electron volts right here. And if you need to convert years to seconds, use this little section here. And then this will automatically transfer that over to this field here. Because most of the tables are in years, but for the purpose of the program, we need to have it in seconds, so there it is. And you can do the reverse. If you know what the Q is, you can get the half-life in seconds here, and the average lifetime here. Okay, wow, that's pretty quick. If you happen to change these numbers, if for some reason some new isotope is discovered, you just click this button here. All right. Well, that's pretty simple. I think that's it for today. Takes care of isotopes. Now, by the way, you can click on table, and you can then scroll up. Let me just. Well, I didn't mean to do that. Let's just go back. Go back. I want to go. I don't know why that's not moving back up. Page up. Let me click show all. Okay, there we go. There we go. Let me hit this right here. Okay, there we go. Much better. So you can see the value of the table. You can, and of course, you can change whatever you need to change as far as the fields that are being displayed here. So I'm going to click back on the form again. Brings us back to uranium. And I'm going to close the screen. All right. Well, all right, that was probably the simplest layout we've seen in quite a while. Please study the reciprocal system and prove it for yourself. For the simplest possible treatment, please obtain my work, The Unmysterious Universe. It's only 80 pages. Very inexpensive. You get it from Amazon.com or TranspowerCorp.com. It has all the concepts. You need to understand the concepts before you can understand the math. It has lots of diagrams to make it easy to understand. It's very, very well organized. There's a section on microcosmos and a section on the macrocosmos. Now, if you do want all the math, then please obtain my magnum opus, which is Existence and Interactions, a computational treatise of the reciprocal system, the true theory of everything. 711 pages in the PDF, 711 slides in the PowerPoint file, thousands and thousands of equations, numerous tables, graphs, figures, everything you need to know to understand the reciprocal system in great detail. It'll take you months to go through that work. Now, once you've done that, then you're ready for these two database modules. Today I covered the isotopes in the Microcosmos database, but you can see I cover solid matter properties, liquid vapor gas matter properties here, and cosmic elements and subatomic particles here, and then photon properties. In the Macrocosmos database, I covered the universe as a whole, galaxy clusters and groups, galaxies, star clusters, stars, planets, moons, minor bodies, nebulae, gas and dust, and voids. Events, if you want to go directly to the events records, instead of going to the actual object and then looking at the events from there, you can just go directly to events. This has a great graphing package included. Same thing with the Microcosmos. We'll get to that later in the in later weeks of the screencasts. Now, my theoretical physics mentor, Dewey Larson, was also a theoretical economist. I've made his work in economics fully computational, just like I've made his work in theoretical physics fully computational. So you can obtain my work, Optimal Economist, and Implementation of Larsonian Econophysics. This covers the microeconomics of individuals, businesses, and business sectors, and macroeconomics of business sectors and countries or regions as a whole. You can read a free online paper I have about the theory. It's called Theory of Microeconomics, Macroeconomics, Larsonian Econophysics. It's a PDF. It's very technical. It's written in MathCAD like most of my papers. But if you want the equations, there they are. Totally, completely supersedes conventional economics, such as Keynesian economics, just as the reciprocal system in physical science totally supersedes conventional physics. All right, again, that wraps it up for today. Please study the reciprocal system and prove it for yourself, and thanks for your attention.